All right, what are the key takeaways here? The first thing is that limits can be used to describe the behavior of a graph around a certain value. And we saw that can be very helpful with some functions where maybe the value we're looking at is undefined or is defined somewhere else, but we can still say some things about the behavior of the function as we approached a certain value. And we'll continue to explore this in future lessons. The main takeaway today, though, is to understand how limit notation works and is read. It must include the LIM abbreviation. It must include the value that x, or whatever the independent variable is, it doesn't have to be x, it can be t or various other things. We need to know the value that x is approaching, and the function being considered. And that all packs very neatly into this limit notation where we can say the limit as x approaches c of my function f of x is equal to some value L. And that means that x is getting close to whatever c is, then the function is getting really close to whatever value that we have for L. And the last thing that we saw today, and it's going to be a really important takeaway as well, is that limits do not depend on what is actually happening at x equals c. It may be a weird piecewise function like we saw earlier in this lesson. We're looking at what is happening as x is getting really close to c. And when we talk about limits, we really don't have any interest at what is actually happening at the value c, just what's happened as we're approaching that value c. So the big takeaways today, the notation is really important. You need to be able to write the notation as well as read the notation, and then understand that we really are not interested at what happens at the value, just what's happening as we approach that value.